Hello, and welcome to Chapter 11 on projectile motion. I'm sorry, not on projectile motion, angular momentum. In this video, we're going to be talking about question 50. Yay! So, this is one of the last ones. Very difficult, very challenging. But hopefully by the end of this video, you'll understand what's really going on. So, angular momentum. Just to start off, there's tons of formulas. Omega, there's moment of inertia, angular momentum. There's just so much going on in this chapter. You really need to pay attention to the variables. But let's begin with the question. A projectile of mass m moves to the right with the speed v. The projectile strikes and sticks to the end of a stationary rod of mass m, length d. So the rod is of length d. Pivoted around a frictionless axle. Find the angular speed of the system. So we know that angular system is omega. That's angular speed. And our answer will be omega equals blank. By the way, in this video, we're only going to be talking about part A. So we're given a few things. Lowercase m is the projectile, v is the speed, m is the mass of the rod, and d is the length. So we're going to have to put w in terms of all these. We're given a picture. We see a ball hitting a rod, distance this, and it's going to spin around in this direction. It's going to make the rod spin. So the first thing that I always like to think about is, what is omega equal to? Well, we know that angular momentum is equal to the moment of inertia times omega. So right off the bat, I think, okay, how are we going to rewrite this? I would say omega is equal to L over I. And from there, I would start figuring out what L is and I is. So I. What is I? Well, I is the moment of inertia, and there's two parts of this that contribute to the moment of inertia. So the first is the rod. The second is the ball. This one is the rod, this one is the ball. So the rod, well, if you didn't know, I is equal to, ignore this 1/12 part for now, I is equal to mr squared. But for a rod, it has a special moment of inertia that has to be divided by 12. Don't ask questions. That's just how it is. With a rod, it's 1/12. With a sphere, it's other things, hollow spheres. So everything has its own moment of inertia. Where a rod, which is spinning, is 1/12. I believe it's the smallest because you're dividing by the biggest number. All right. So this rod, obviously, we have 1/12 md squared. That will contribute to the moment of inertia. And so that was the mass of the rod times distance squared, 1/12. This also would be added to the mass of the ball, because that's also contributing to the moment of inertia. Its distance from the center squared, mr squared. R equal d over 2. So this contributes to the moment of inertia. So L, that's the other one we need to figure out. We know that L, or angular momentum, is equal to momentum, P, times a radius. Radius being d over 2, and P equals m over v. We solved it. L is equal to d over 2 mv. We know we solved it because we put it in terms of only this, d mv. We know we solved I because we put it in terms of all this. So now we can divide the two together. So with L being on top, and then I being on the bottom, the big formula. And when we figure out all the algebra, you get this great answer. And that is the answer to section A of this question. Thank you.